Okay, grade 10. So just following up from last lecture on talking about elements and atoms, we kind of ended the lecture talking about, well, once we've isolated all these different elements and figured out what all the building blocks are, let's kind of go through each building block and say, well, what are the advantages and disadvantages of each building block? What are its strengths and what are its weaknesses? What's its boiling points and so on and so forth. So what those things are called are basically physical and chemical properties. So we've kind of looked at each element and analyzed a whole bunch of different things about them. Okay, we kind of want to look and know everything about each element. And we've kind of broken knowing everything about each element into kind of two main categories, physical and chemical properties. Okay, so let's go through that today. Now this should be, again, recap from grade 9, so we're not going to spend a tremendous amount of time on it. So a major task of chemists was to look at each element and analyze everything about it, like I just mentioned. Chemists wanted to know everything there was to know about each element, its weight, its color, its size. What is it good at, its abilities? What is it bad at, its weaknesses? Whether it's reactive, whether it's not reactive, whether it produces radioactivity, whether it produces radiation that can potentially kill you. Okay? So chemists first looked at each element's physical properties. So before they started kind of combining different elements, they first wanted to say, okay, let's just put this element kind of essentially on a table and let's just look at it. Okay, we'll use our senses and we're going to kind of just describe it, like, what does it look like? Does it feel hard? Can I bend it? Okay, so what those things are called physical properties. And the best way of kind of looking at physical properties are simply describing the element by simply observing it and making some simple measurements. Okay, how the element is on its own. So you can still measure things. You can say, oh, well, it weighs this much, okay, if I have a certain size sample. You can say, oh, this is the density. This is what it melts at. This is what it boils at. This is when it turns to a gas. Okay, those are some very common physical properties. You would describe its color, a very common thing to describe. Whether or not it's solid, liquid, or gas. Okay, those are all different physical properties. All right. So when you look at different elements, so I have several different elements here. So I have sodium, okay, so that's a metal. Okay, and the symbol for sodium, just want to remember, it's not S like it should be, okay, it's Na, because S stands for sulfur. So we've got sodium element, we've got titanium, this is right here, this is carbon. And then I've got oxygen gas. So this is 4 different elements. Again, there's about 118, I've just picked 4. So what scientists have done, or what chemists specifically have done, is they wanted to know all the physical properties of all these different elements. Okay? Not just the ones I have listed here, but all the different elements. So they would take a certain size of each sample, say, okay, let's take a certain, like 3 cubic centimeters of sodium, titanium, carbon, and oxygen, and then let's weigh. So they're all the exact same size. What does each one weigh? Which one's heavy and which one's light? Okay? And they'd say, well, what is the color? They'd also say, well, what color is each one? Oh, this one's a metallic color. This one's a metallic color. This one's black. Oxygen is transparent or clear. They would say, oh, is this one hard? No, this actually metal you can bend with your hands. Okay? Titanium, you cannot bend that with your hands. It's a very, very strong metal. So there's some differences. If you want a metal that is bendable, and you may think, well, when would I ever want to bend a metal that's bendable? Well, metals are really convenient for conducting electricity. So if you have to make something that bends and conducts electricity, sodium would be a better option than, say, titanium. Okay? Looking at carbon, okay? Carbon obviously is not going to be it's very hard, but it's very brittle, so it doesn't bend, another physical property. Oxygen, there's no hardness at all. It's not even a solid. Okay? You would look at the density, okay? And look and say, okay, well, how dense is each material? Based on the size of it, how heavy is it? Okay, so you can go through the density, and obviously oxygen's going to be it's not going to be very dense at all. Carbon's not going to be very dense. Titanium's a pretty dense metal compared to sodium. Okay, and then again, like I mentioned, the boiling point of each of these. So these are all different physical properties. So the main thing I'm getting across here is they've gone through each element and know everything about them on their own. Okay, now we didn't just want to know how they are on their own, because in reality, if we're going to start using these elements for building blocks, we know they're not just going to be sitting on their own. They're going to be touching things, okay? Just like how I touch a table or I touch a computer, okay? Or a piece of plastic is going to touch a piece of glass, or a piece of metal is going to touch oxygen, or a piece of metal is going to touch another piece of metal. We have to know, well, if these two things touch, what's going to happen? Okay? And what those are called chemical properties. So along with knowing all the different physical properties, So after looking at all the different physical properties, chemists wanted to know how each element reacted to things around them. And that's what chemical properties are. You basically take an element, okay, expose it to something like, oh, I'm going to expose it to oxygen, or I'm going to expose it to plastic, or I'm going to expose it to an acid, or I'm going to put it and touch wood with it, or I'm going to touch lead with it and see what happens. Okay? Those are what we call chemical properties. And they're describing how one element reacts with other elements or compounds around them. Okay? How an element behaves with other pieces of matter. Okay? The way I kind of remember it with chemical properties, if you think of saying, oh, somebody has chemistry with somebody else, they're talking about how you interact with between two people. Okay? And that's what elements are. Okay? You're basically kind of figuring out, do these elements have chemistry between them? Do they react with things? So let's go through a couple of examples. So if I use my same elements again, along with after figuring out their physical properties, they would look at sodium and they would say, oh, okay, well, let's take a look at sodium and see, does it react with air? Okay? And it does, okay? It doesn't react very violently with air, but if you take a piece of sodium and you just put it onto a table, it starts to react with oxygen, known as corrosion. Now, every single metal does this. There's not a single metal that doesn't react with air, okay? And it's one of the disadvantages of it. Now, some react with air a lot faster than others, okay? And the ones that don't react with air very fast are really, really valuable metals like gold and platinum, okay, and silver. That's one of the reasons, now there's more than just that, but that's one of the reasons why they're so expensive. We don't want to make jewelry out of metal that corrodes or turns a bad color after a year or 2 years. So we try and make jewelry and even coins, okay, out of metals that don't corrode. And we only know which metals don't corrode from chemists going through and figuring out their chemical properties. Okay. We also want to know, is it flammable? Okay. So most metals are not flammable. Sodium happens to be. Okay. Sodium will actually light on fire. It's weird to think of a metal actually light on fire, but sodium is able to actually produce a flame. Titanium is not. Okay. You can't do that with titanium. Does it react with an acid? If I take this piece of metal and I drop it in an acid, does it do anything, or does nothing happen? Okay. What if I take this piece of carbon over here and drop it into an acid? What happens? Okay. What if I take oxygen, okay, and drop it into an acid? What happens? Okay. And then the same thing if I drop it into a base. Okay. Another interesting thing, what if it reacts with water? Okay. An interesting thing about sodium is that it reacts with water and it'll actually burst into flame. So if you throw this piece of metal into water, it's actually going to blow up. Okay, it's very surprising. Okay, it's something that they would have figured out, because if you throw titanium in there, it doesn't do it. If you throw iron into metal, it doesn't do it. If you throw nickel in there, it doesn't do it. But if you throw sodium, if you throw lithium, if you throw cesium or francium, any of those metals into water, it makes a fairly large explosion. Okay? So again, something that they had to figure out. So obviously, if we're going to make a boat, we want to make sure that we don't have any sodium metal on that boat, because we know that that boat is going to go in the water, and we obviously don't want an explosion. Okay. Now, once we know all these different physical and chemical properties, okay, and that was a big task of chemists, now what a lot of manufacturers do, and this is what a job would be as a chemist, is manufacturers come to chemists and they say, well, which material should I make my product out of? Like if I'm going to make, say, this Tide container, which material should I make it out of? Now, it's made out of plastic, but why did they choose that? Why did they choose plastic? Why didn't they use, say, like paper product? Why didn't they use glass? Okay, why didn't they use metal? Okay, there's reasons why they made that product out of that material. Take a look, another product like, say, paper towels. Okay, which material should we make it out of? Well, that seems pretty obvious because it's paper. But what kind of paper? Okay, there's multiple different types of paper. Which one's the most absorbent type of paper? But again, that would be the physical properties, or chemical properties, kind of putting two materials together and seeing how they react. Okay, when they make Downy. Okay, they make this cleaner. So they've made the cleaner, but before they can release it to the public, they have to say, well, how does this cleaner react if it lands on someone's skin? Okay, does it make them burn, or does it burst into flames? Because we know that when people are handling Downy, there's a chance it might land on their skin. Okay? What if it lands on the dryer, the metal part of the dryer? Does it burn through, or does it make a reaction? What if it lands on a piece of wood that's in someone's room? Does it make a reaction? What if that piece of Downy drips onto some tile that people have on their floor? Does it make a reaction? chemists have to ensure that that doesn't happen, or they're going to be major lawsuits. Okay? You can look at some other products, like say sunglasses. Okay? Physical properties, well, we can't make them out of a metal that doesn't bend. You would never see sunglasses made out of iron because iron doesn't bend very well and it's super heavy. So we're like, okay, well, we can't use iron. They would go to chemists and say, well, which material should I use? Someone might suggest you should use titanium, or you should use a combination of titanium and copper, or you should use nickel and a little bit of chromium, combination, whatever metal that chemist chooses, because the metal actually has to be a little bit bendy, but we don't want it to corrode because it's going to be out in the air. It might get wet, so we don't want it to react with water. Manufacturers go to chemists to basically figure all this stuff out and figure out what should I make this material out of. And it's way more complicated than you originally think. You may think, okay, if I'm going to make a pair of shoes, well, I'm obviously going to make leather. Right? Well, what kind of leather? What kind of protective coating are you going to have to put on that? Have you checked to ensure that the leather doesn't react with people's skin if it's going to be on there? What about people's skin that has moisturizer on it? What about, does the leather react with suntan lotion? Does the leather react with makeup products? Does the leather react with nylon? Does the leather react with jean material? Does the leather react with socks? Does it react with silk? Okay, it's much more complicated than you originally think when you choose a material. So I hope that that helped, and I will be posting some learning checks shortly.